The last group of functions we're going to look at for differentiation are the inverse trigonometric functions. So hopefully you can remember how the inverse trigonometric functions were defined. Again, I expect you to know the product and the quotient and the chain rule for differentiation at this stage. Here I have the derivatives. I've got the intervals. If you remember how we defined the trigonometric functions, we limited the intervals so that I can have a one-to-one function to get the inverse of. So here's the derivatives. Now, at the end of this playlist, I'll show you where sine and cos come from, the derivative of arc sine and arc cos. But for those we do not use the definition of the derivative, we're going to use implicit differentiation. But I'll show you that in a later video. So let's take a look. The derivative of arc sine is 1 over the root of 1 minus x squared. Now, when I say arc sine, it's the same as sine inverse. Now, the challenge here is that we don't read this as sine to the power minus 1. So we don't want confusion, so watch out for that. And arc cos and arc tan, that's why it's sometimes nicer to write arc, but if you see sine minus 1x, we will assume that that is the inverse function as opposed to sine of x to the power minus 1. So there's the derivative of arc sine, arc cos, and arc tan. 1 over the root of 1 minus x squared. Notice cos is just the negative of the derivative of arc sine. And then tan is 1 over 1 plus x squared, no root there. So let us see. The other three gets a bit more messy. Arc sec, cosec, and cot. Again, cosec and cot are just the negatives of sec and tan. So if you know sine, sec, and tan, the others are the negatives of those. But arc sec is 1 over x times the root of x squared minus 1. So let us use these. I've got 3 examples here, one with sine inverse, one with tan inverse, and one with cos inverse. I've got their derivatives on the right hand side there, if you haven't learned them yet. So let's take a look. The first one is arc sine of x cubed, or sine inverse of x cubed. So it's sine inverse of a function. So the derivative of that is, now that x cubed, I'm not thinking of that yet because it's arc sine of something. So the derivative of arc sine is 1 over the root of 1 minus, now here I've got an x, whatever is there, I've got an x cubed, squared, times the derivative. The chain rule tells me now I can multiply it by the derivative of x cubed. There we go. All right, the next one. Tan inverse or arc tan squared. So now it's the whole thing squared. So the derivative of something squared is 2 times that thing to the power 1 times the derivative of that thing. What is that thing? That thing is just arc tan of x. So 2 times arc tan of x to the power 1. We can just say 2 times arc tan x times the derivative of arc tan, which is 1 over 1 plus x squared. This third example, hopefully you notice, first thing we look at is one function times another. So it's the product rule. We'll worry about the functions later. First, it's the product rule. So the product rule tells me the first function times the derivative of the second. All right, what is the derivative of the root of ln x? Now, I've got the root of something, so that derivative is 1 over 2 root, same thing, times the derivative of that thing. What's the derivative of ln x? 1 over x. So there's lots in this part. Now the second part of the product rule, plus the derivative of the first part. So it's an arc cos. So my derivative, there's a minus. So I can put it in brackets, minus 1 over the root of 1 minus x squared. But now I don't have an x, I've got this whole thing. X squared minus 1 squared. Times the derivative of x squared minus 1, which is 2x. I'll just write it in the numerator. Still busy with the product rule. First one times the derivative of the second, plus the derivative of the first times the second. There we go. So that is the derivative of that function. So when you do derivatives, doesn't matter what types of functions you have to look at the function as a whole and see, where do I start? What's the thing happening here? Is it a product or a quotient? Is it something raised to the power? What's the outside function? And move your way in. And don't rush it. Systematically make sure that you differentiate each function. I'm also, at the end of this playlist, I'm going to put a series of mixed examples just for practice. So if you want to practice your differentiation, but with some making sure you've got the right answers there, we're going to do that as well in this playlist. So that is the derivatives of inverse trig functions.